So coordinate geometry. In the last lesson, we started coordinate geometry and we derived this formula. What was the name of this formula?
Distance formula.
Yes, distance formula. It is used to find distance between 2 points on the plane if their coordinates are given. Today we will discuss some more questions related to this formula. Okay, no new concept today, only some questions. Okay. So now we move to first question to solve using this idea, the distance formula. Do the points form a triangle? If so, name the type of triangle formed. So 3 points on a plane are given. 3, 2, -2, -3 and 2, 3. And we want to check whether this length, the distance between these 3 points forms a triangle. And if so, is this any special type of triangle? We want to give name. We know different types of triangles: equilateral triangle, isosceles triangle, right triangle. We want to check which type of triangle is this. So similar questions you can expect. So what we can do is we can give names for the points. So I give 3, 2 as A, and -2, -3 as B, and 2, 3 as C. No need to draw the pictures here. Simply find the lengths of AB and BC and AC. Okay, AB, you find AB, the distance between 3, 2 and -2, -3. And also find the distance between -2, -3 and 2, 3, that is BC. And the distance between 3, 2 and 2, 3, that is AC. Okay. And you know, if 3 lengths are given, what is the condition to form a triangle? There's a relation, right? Can you form a triangle with small sticks of lengths 2 centimeter, 2 centimeter, and 6 centimeter? Can you form a triangle if you got 3 sticks of lengths 2 centimeter, 2 centimeter, and 6 centimeter? Can you form a triangle?
No.
No. So there's a condition, right? What's the condition?
The sum of two sides is less than the third side. More than the third side.
Yeah, more than the third side. The sum of the 2 smaller sides must be greater than the largest side. Okay. So here 2 plus 2 is not more than 6. So using these sticks we cannot form a triangle. Okay. But if it was 2, 5, then 6, then we can form, because 2 plus 5 is 7. That is greater than the largest length given. Okay, so this is possible. So similarly, you can check here. So you find AB and AC and BC. You can draw in your rough book. Simply find out the length AB, BC, and AC now. What will be the length AB? Use the formula. I shall write the formula here. AB is equal to square root of x1, x2 minus x1 all square plus y2 minus y1 all square. This is the formula, distance formula. Okay, so what will be the length AB here?
Root 2.
Root 2.
Root 2.
Root 2. Okay, I think we can check here. So root 2, we will check it. Okay, so square root of when we find AB, x1, y1, you can choose this point. x2, y2 will be the second point. So that means x1 is 3, y1 is 2, x2 is -2, and y2 is equal to -3. So you substitute these values in this formula. Okay, so what will come?
-2.
-2 minus 3.
-2 minus 3 all square plus
-3
-3.
minus 2
-3 minus 2 all square. So this is another problem. You have to be very careful about the signs. Okay, negative number will come in the distance formula. Okay, so next line you can reduce this. What is -2 minus 3?
-5.
-5.
So -5 square plus what is -3 minus 2?
-5.
-5.
-5 square. Very good. So next step, what's -5 square?
25.
-25.
25. Simply 25 plus again
25.
So
50.
this
50.
root. Okay, so better you simply write root 50. I think that's enough. So there's a possibility to write reduce this.
Root 5.
Yeah, you can write root 25 into 2, then you can write to 5 root 2. So anyway, we keep like this to compare the lengths. So simply keep like this. Okay. So now take the next length, that's BC. BC, how will be the BC? BC length of BC. So when we find out BC, we want to give names. X1, Y1, you can choose B, and X2, Y2, you can choose C. Okay. So what will be square root of X1 minus X2? What will come here? X1 minus X2.
2 minus.
2
minus minus 2.
2 minus minus 2 will come, and square plus Y2 minus Y1.
3
3
minus
minus
3
minus 3.
minus 3.
Minus 3. So next step, what will come? All square, okay? Next step,
Minus
2 plus 2.
2
2
plus
plus
2 square. 2 plus 2 square means 4 square.
4 square.
Plus here
Plus 6 square.
6 square. So next step, root of
Root
16 plus 36.
36, that is equal to
52.
52.
it's equal to root 52. Okay, and third length is AC. Third length is AC. How will come AC? Let's have it here. AC is equal to, how will come? Square root of, first you take the difference of x coordinates. So 2
minus
minus
1.
2 minus 3 square plus
3 minus 2.
3
3
minus
minus
2.
2 square.
Whole
3
square.
minus 2 all square. Okay. So next step, that is minus 1 square, right?
Minus 1 square.
Minus 1 square plus
1 square.
Minus 1 square.
1 square. Okay, so that is square root of
Root 2.
2.
root 2. Okay, 1 square plus 1 square will be 2. So root 2 is equal to AC. And 52, root 52 is BC. And root 50 is
AB.
clearly here the largest side is BC, because BC is root 52, that is larger than root 50 and root 2, the other two sides. And here BC is equal to root 50 can be written as root 26 into root 2. Okay, root 52 can be written as root 26 into root 2. You know the multiplication of irrational numbers. Root 26 into root 2 will become root of 26 into 2, that is root 52. So we can split root 52 as root 26 into root 2. The other two sides also you can split like this. AB is equal to root 50 is equal to, we can write this as root 25 into root 2, that is 5 root 2. And third side AC, that we don't have to reduce, this is already root 2 itself. Okay, so to check whether ABC forms a triangle or not, what we have to do, we want to check whether the sum of the smaller two sides exceeds the larger side. So we can check here, what is AB plus AC, the sum of two smaller sides, that is equal to 5 root 2 plus root 2. So that is equal to 5 times root 2 plus 1 root 2 will become 6 root 2, right? So you compare, is 6 root 2 greater than root 26 root 2 or not? True or false? 6 root 2 is the larger, right? Because you look here, root 26 is less than 6, right? Because 6 means root 36. So 6 root 2 can be written as root 36 root 2. But here only root 26 root 2. So clearly the sum of the two larger sides AB plus AC, or 6 root 2 is larger than the largest length BC, that is root 26 into root 2. Hence we can say that ABC forms a triangle. Okay, so is this an equilateral triangle?
No.
No. Is this isosceles?
No.
Okay, sometimes the question may be given lengths, maybe we can form a equilateral or isosceles. So how you can check it, equilateral or isosceles?
Equilateral
All the
outside
sides are equal.
Yeah. For equilateral triangles, the sides will be equal. For isosceles,
Two sides will
Two
be
sides
equal.
will be
two
equal.
sides will be equal. So this is not isosceles or equilateral. So next you check whether it is right triangle or not. That's what you check here. Okay. How to check whether it is right triangle or not?
AB square is equal to BC square plus AC
Yeah.
square.
Here which is the largest side?
Root
Root
52.
52.
BC. So you simply check whether BC square is equal to AB square plus the sum of the squares of other two sides or not. If this relation satisfies, we can say that this is a right triangle. So here what is AB square? AB square plus AC square. What's here AB square?
50.
AB is 50. Okay, root to 50 square. Root to 50 square.
50.
Okay, that will come 50. Okay, because we can cancel root and square. Plus AC square. What is AC square?
2
Root 2.
2 square.
2 square.
Two.
That means 50 root to 50
plus
square
2
is 50 plus
plus
root
2.
2 square. That is simply 2. That is 52. Okay. So AB square plus AC square is 52. We are doing the left side and right side separate. This is RHS. Okay. No, the largest side. The largest side. Okay. So here root 52 is the largest among root 2, root 50 and root 52, right? That's why I wrote a BC square. Okay. In other way also you can write the Pythagoras theorem. At that time the sign will become minus here. Means AB square, you can write AB square is equal to BC square, the hypotenuse square minus the second perpendicular side, that is AC square. What the LHS of this equation is BC square. What's BC square here? BC square. This is LHS.
Root to 52 square.
Root
Yeah,
52.
root to 52 square. What is root to 52 square?
52.
52.
52. So here RHS is 52, LHS is 52.
RHS is
That is
equal to LHS.
BC square is equal to AB square plus AC square. The condition for a Pythagoras theorem is satisfied. Okay. That means if Pythagoras theorem is satisfied, this given triangle is a right triangle. The Pythagoras theorem will satisfy only in right triangles. Okay. So given triangle is a right triangle. That's the answer to the question. Okay, so today we discussed only one question, and there are many application problems. We will see some different types of problems in the next lesson. So you have to memorize this formula. Okay. So PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square.